Yo, what's going on, class? I am going to be talking about worksheet number 5-10 today. I'm going to do a couple problems. I'm going to do number 1 and number 3. Number 1, just to get you guys started thinking about it, it's kind of a challenging problem, but it's fairly simple. There's one aspect that's kind of tricky. And then number 3 is a hard problem that I really want to go over. All right, so starting off with problem number 1. Problem number 1 states, at Niagara Falls, 150,000 gallons of water per second fall through a height of 22 meters to the rocks below. How much power does this represent? Now, 1 gallon of water has a mass of 3.79 kilograms. So right now I'm going to write down all the givens that we have, and then I'm going to solve for the problem. So key thing here, though, if you read it carefully, it says 150,000 gallons of water per second. So that means that every second, 150,000 gallons of water hits the rocks below, right? So that is your time frame. That's the time we're going to be looking at, is 1 second, all right? So let's write down the givens. So we start off, mass is going to equal to 150,000 gallons times the mass of 1 gallon, which is 3.79 kilograms. So the mass is going to equal to 150,000 times 3.79. So our mass is going to equal to 568,500 kilograms. All right. It has a height of 22 meters. All right. And like I said before, because it says per second, our time frame is actually going to be 1 second. All right. And we are solving for power. Power equals question mark. Now, since it's falling a height, that means that what kind of energy is being used? All right. Potential energy. All right. So power is going to equal to potential energy divided by T. Now, our equation for potential energy is mgh divided by T. So therefore, power is going to equal to our mass, which is 568,500 times 9.8 times a height of 22 divided by 1. All right, so we get a power of, it's going to be a really large number. Now, if you notice, at the bottom of the worksheet, there's an answer key. Now, the answer key says an answer of 122 MW. Now, the capital M stands for mega, and I'll go over what that means. So the actual answer comes out to be 1, 2, 2, 5, 6, 8, 0, 0, 0 watts. All right. Now that is the same thing as saying, for example, 123 megawatts. All right. Where's that? Megawatts. That's a little better. All right, so a megawatt, mega, M, stands for times 10 to the 6th. So that's 10 times, that's 10 to the 6th power. So it's 1, 2, 3, 4, 5, 6, 6 decimal places over to the left to make it 123 megawatts. All right, that's problem number 1. All right, now we're going to jump to problem number 2. All right, so now let's work on number 3 from 5-10. All right, number 3 says, a bricklayer lifts a 1.2 kilogram bricks and places them on a 140 centimeter high wall. If the bricklayer puts in an 8-hour day working at a rate of 0.050 horsepower, how many bricks does he lift? So we have a couple things. Like we have to do a conversion, we have to do a couple conversions, and then we have to just figure out how to solve this problem. All right, so let's first write down everything that we're given. So we're given the mass of an individual brick is going to be 1.2 kilograms. So M equals 1.2 kilograms. All right. Now, the bricklayer is lifting 140 centimeters, which is a height of 1.4 meters. So remember 100 centimeters equals 1 meter. So if you have 140 centimeters, that's 1.4 meters, right? Because there's 1 meter for every 100 centimeters. We have 40 additional centimeters, so it's 0.4 meters. All right. Now the total time spent, I'm going to call this T total, is equal to 8 hours. Now we have to convert hours into seconds, right? We never want to use hours. So 8 hours converted to seconds, there's 60 minutes in 1 hour, and then there's 60 seconds in 1 minute. So we do 8 times 60 times 60, and that gives us 28,800 seconds. All right, so that's 28,800 seconds in in the 8 hour span. Now he's working at a power. He has a power of 0.05. That's a 5, not a 6. Let me erase that. All right. 5 horsepower. Now, at the top of the sheet, there's a conversion. It says that in parentheses, it says 1 horsepower equals 746 watts. So it's converting horsepower, which is another unit for power. All right. It's like meters per second in miles per hour, right? So that's like there's different types of units for power. So 1 horsepower is our common unit that we use for like cars, lawnmower engines, electric motors, anything like that. So we're going to convert horsepower into watts. So for every horsepower, every singular horsepower, there's 746 watts. So to get from horsepower to watts, we're going to do 0.05 times 746, which gives us a horsepower of, gives us a power of 37.3 watts. All right, so that's a power of 37.3 watts. That's a conversion. That's the value we are going to be using. All right, so we have the mass of an individual one singular brick. We have a height that one singular brick travels, and we have the power for one singular brick. So we have a lot of information for one singular brick. All right, so what we can do from here is actually we can solve for time to lift one singular brick. And we can use that to help us figure out how many bricks does the bricklayer lay. All right, so we know that power is equal to potential energy over time. All right, time and power are going to switch because we're going to solve for time. We're going to remember, this is the time to lift one singular brick. All right, so we get a new equation that says time is equal to potential energy over power. Okay, so time is going to equal to mgh divided by p. So that's going to equal to 1.2 times 9.8 times 1.4 divided by, now we're going to use our wattage, all right, our conversion from power to from horsepower to watts of 37.3. All right, and we get a time of 0.44 seconds. All right, now that's the time for one singular brick. All right, so the number of bricks is going to equal to our total time divided by t, because total time is 28,800 seconds, and our t value is 0.44 seconds per brick. So when we do total time divided by time, we're left with a value of bricks. We're left with bricks. So that's going to equal to 28,800 divided by 0.44, and we get an approximate value. Now, it comes out to a little bit greater, but we get 65,000 bricks, which is the answer at the bottom. So the number of bricks equals 65,000. Okay? Hopefully that makes sense. Stay tuned for the next video, which should be the 5-9. I'm going to do a couple problems from that as well. All right, see ya.